This video is a continuation on the introduction to MATLAB. We'll learn how to create a script file in MATLAB. We'll introduce some useful notations in MATLAB, the difference between the dot before an operator and not having it before the operator, which is the difference between element-wise operation and matrix operations. Next, we'll talk about sublets in MATLAB and how to create them, for loops, and how to create a user-defined function in MATLAB, and finally we'll talk about the function Linspace and when to use it. First of all, remember that for the file name in MATLAB, you cannot use special characters in the file name, including a space. The file name must start with a letter, and it could use a combination of letters, numbers, and underscores, but it must start with a letter. Try to use comments as needed, and please remember to put your name or your names in the header of the file as a comment. And finally, add a comment before solving each exercise to let the reader of your code knows which problem you're trying to solve. Some of the useful notations in MATLAB include the end, which is used to indicate or to denote the last index in an array. So if you don't know the last index in an array, you could use end, or you could use length of that array. The colon notation, we use it when we want to specify a range of elements. For example, when we say 1 through say 4. So we have a range of elements between 1 until 4. Another way I can use this is to create or to extract elements from an array. Assume I have this array, for example. Then saying x 2 until end will give me the elements from the second until the last. Okay, and the apostrophe in MATLAB is the transpose operator. These are some examples on these short notations that are useful in MATLAB. For example, the colon can also be used to extract all the rows or all the columns in a matrix. So saying x bracket colon comma 1, since I didn't specify a row number, but I did specify a column number, this will give me column number 1 from x. Regardless of the row number, I will always output whatever is in column number 1. Let's look at an example on this. So I will create a matrix, for example, uppercase X. The way to create a matrix in MATLAB is similar to the way to create vectors, except when you want to move to a new row, you have to put a semicolon. Remember, to separate elements in a vector, you could use spaces or commas. But to create a new row in a matrix, you have to use a semicolon, or you could put the next row in a new line of code. I prefer semicolons, and sometimes in some cases, it is preferred to use both at once, meaning add the semicolon at the end of the row, create a new line, and then continue with your next elements. I'm going to create a 3 by 3 matrix. So these are my elements. I will close the matrix and then hit enter. If I type X, I will see matrix X. Going back to this command, we mentioned it will display the first column, the elements in the first column of X, as such. If I want the elements in the first row of X, I will have to say first row, and I don't care about the column number. So this is another way you can use the colon notation, besides the range, which is 1 through 4 that we saw earlier, to create an array with a specified starting value with an increment and so on. Another way is to extract elements from a matrix or an array. See, this will display the first row in X, which is 1, 2, 3. Here we have an example of two notations together. The colon notation, which will give us the range of elements between index 4 and index 10 in this case, and then I'm calling the transpose operator. So what this will do is extract elements at 4 until 10, and then convert this into a column vector, assuming X is a row vector. I will do a quick example here. CLC to clear the window. I would say X is equal to, I'm going to overwrite X. So this is my X. Okay, I want to extract a few elements first. Say X 3 until end. Okay, and then transpose that. So instead of giving me a row vector having 6 and 7, I got a column vector because of the transpose operator here. Here, I'm creating an array whose elements are extracted from X. So what I did is I put half of X, assuming X is of size 10 or length 10, I put the right half of X on the left and the left half of X on the right. So I swapped the elements on the right and the elements on the left from X. Again, I'll do this in MATLAB. So let's create some easier X so we can look at it clearly. I'm going to assume X has 10 elements ranging from 1 to 10. Calling X from, I'm going to create a new matrix or a new array having elements from X starting from the 5th until the end, comma. So the next part of this array will have elements from index 1 until index 4. Or let's do from 6, for example, to end, and then from 1 to 5. So we'll have 5 and 5. What this will do is it will swap 6, 7, 8, and 9 with 1, 2, 3, 4, 5. So let's look at the answer. Yeah. Next, we will talk about element-wise operations in MATLAB versus matrix operations. Before I talk about this in details, let's remember how we can do matrix multiplication. I'm not going to do this in details, but we said there had to be a condition that needs to be met, which is the inner dimensions must agree. And in this case, both matrices are of size 2 by 2. They have 2 columns, 2 rows, and 2 columns. So 2 rows and 2 columns, 2 rows and 2 columns. The inner dimensions of both of these matrices agree. That's why matrix multiplication was possible. And the way it works is that we multiply the rows by the columns. So 4 times 0.6, 7 times negative 0.2, and then we add these results, and that will give us the first element in the output, and so on. So it's a bit of a lengthy process to multiply matrices, and we have to check for the condition of the inner dimension, whether they agree or not. Otherwise, if they don't agree, we cannot perform multiplication between these matrices. And remember, we said MATLAB is short for matrix lab. So whenever we try to multiply 2 matrices together, or 2 vectors together in MATLAB, MATLAB will assume we want to do matrix multiplication by default. So let's look at this example here. We have 2 matrices, both of size 2 by 2, 2 rows, 2 columns. The first matrix is A, second matrix is B, and they have these elements. In MATLAB, if you type A times B, like this without the dot, it will perform matrix multiplication between these matrices. And it was allowed, it is allowed to perform matrix multiplication because of the inner dimension. They do agree, so we were able to multiply them together as matrices. And if you remember, as matrices A and B, for the matrices A and B, multiplying B times A is not the same as multiplying A times B. This is B times A. If you calculated it in MATLAB, this is A times B. They're not the same. However, if you put the dot before the multiplier operator, the multiplication operator, then what you will do is actually multiply 1 by 2. That will be the first element in the product. And then 2 by 0, 3 by 1, finally 4 by 2, which will give you 2, 4, 7, and 10. It's not going to give you that. It will give you 2, 0, 3, and 8. Yeah? And if you type B dot times A, that will be equivalent to A dot times B. Why? Because 1 times 2 is equal to 2 times 1, and that is the first element in this output. 2 times 0 is also 0 times 2. Because if A and B were numbers, not matrices, or if they were just scalars, then A times B is equal to B times A. So this is one huge difference between putting the dot and removing it. It does element-wise operation. If your intention is to multiply each element in A with the element lying at the same location in B, then you must put the dot. The dot means this is an element-wise operation. And remember to put it before the operator, not after. I will do a quick example on element-wise operation before we see the example in the slide. So let's do x is equal to 1, 2, 3. Y is equal to 2, 4, 6. If I call the size function on x, this is the size of x. It's 1 row, 3 columns. Size of y, it's clearly also 1 by 3, but let's output it this way. Now the inner dimensions are 3 and 1. 3 and 1 are not equal, so multiplying x times y like this, MATLAB will attempt to do this multiplication as a matrix multiplication, and it will not work. It will give you an error saying that the inner dimensions must agree. However, if your intention is to multiply 1 by 2, 2 by 4, 3 by 6, then you must put the dot because this is an element-wise multiplication. Okay, let's look at the case where, again, let's look at x and y separately. So this is x, this is y, it's 1 by 3, 1 by 3. If I take the transpose of x, I'm going to get a 3 by 1. So x is a 3 by 1, x transpose is a 3 by 1 matrix. So if you don't believe me, we can check for that. So the size of x transpose is 3 by 1. Size of y is 1 by 3. So the inner dimension becomes 1. That means it is possible to do this matrix multiplication. And the result will be the outer dimension, which is 3 by 3. Okay. Now we'll do an exercise on how to plot in MATLAB, as well as it will also help us understand element-wise operations. Okay. The question says plot x squared, the function x squared, for x is equal to minus 3 to 3. So x is between minus 3 and 3, inclusive. Or we can also say x is less than or equal to 3 and is greater than or equal to minus 3. Yeah, I'll start solving the first part of the question. Y is equal to x squared, x is minus 3 to 3. Before I call y is equal to x squared, I have to define x. Okay, let me put all of this into a script file, which is one of the overview, one of the topics that were in the overview. So all of the things I type here will not be saved later on for me to submit or edit. For this, I'm always going to create a new script file before I start working. At the beginning, I will type clc clear all. Clear all will erase all the variables that are in the workspace. clc will erase the command window. Let me click run. The first time you click run, if you don't have a saved file, it will ask you to assign it a name. I'll call it lab 1 2. It's not lab 12, lab 1 and 2. Okay. And I comment with my name, for example. I will say example. Okay. We said we want x to be ranging from minus 3 until 3. Semicolon. The question didn't provide me with the increment value, so it is up to me to decide what increment value to use and whether 1 is a good enough increment value or not. Let's look at the question. The function here is not linear, clearly, right? So an increment value of 1 is not good enough. I'm going to be a bit generous. I will use 0.1. You could use 0.2, whatever. 0.1 will also work. Okay. So this is my x. Now y is equal to x squared, and we want to plot that. Y is equal to x squared. Remember, I want to square each element in x because I'm creating points, and points are pairs that require an x value and a y value. So for each x value, I will have a y value. Since I said the keyword each, I have to use the dot. Otherwise, without the dot, MATLAB will assume you want to do matrix x times matrix x, which is not what we want. Okay. Now, the next part is to plot it. Remember to put the independent variable first. In this case, it's x, then the dependent variable. If I run this file, I'm gonna get a graph, but it's missing labels, so I'm gonna add a title and labels for my axes. Let me add an x label. I will say x, close the bracket, and y label is y. The title can be plot of y of x. Now if I run the file, I will see a complete graph with a title, x value, x label, and y label right here. Okay. The next part of the question asks me to plot another function, which is x squared divided by sine squared x plus 1 on the same graph. So f is x squared divided by sine squared x plus 1. Remember that sine squared of x is actually sine of x squared. So evaluate sine of x and then raise it to power 2. So I'm going to create, before plotting actually, I will define f as x squared dot divided by, the space is optional here, I'm just typing it for clarity purposes, divided by, open a bracket because I want to evaluate the whole denominator first, which will be consisting of sine of x squared plus 1. Sine squared x plus 1, this is the entire denominator. In the numerator I have only x squared. So this is f. The question says plot these two functions on the same graph. I'm gonna do it in one line of code saying plot x, y, comma, x, comma, f. Okay? And then click run. Now I have two plots on top of each other. If you wanna modify this, now you can have a legend instead of the y label. The legend will be function f y first, right? That's what we plotted first, and then the second function was f of x. because we have two graphs, so labeling the y-axis maybe is confusing. Y of x. The title, I will change it to plot of y of x and f of x. Now you will see that you added a legend to the graph. The blue signal is y of x, the red signal is f of x. The title is still here, the x label is still x. So this completes the whole exercise. Just try to review it, make sure you covered every part of the question. The next part we will go over is sublets in MATLAB. In the example we saw just now, we have one figure window with two graphs on top of each other. What sublets allow you, or what sublet function allows you to do, is to have one figure window with multiple plots in it. And the way it works is as such: sublet, open a bracket, you specify how many rows and how many columns you want in your grid. So the figure window will be divided into these many rows and these many columns. So if you multiply them together, it will give you how many locations you have in your grid. In this case, it's a 2 by 2 sublet. So the number of rows is 2, the number of columns is 2 as well. And the last entry you need to provide it, or the last parameter you need to specify, is the location in which you want to put that plot. So plot of y of x will be located at location number 1. For example, if you put number 1 here. Okay, I'm going to modify my code in here so that instead of having these two graphs on top of each other, I will want them in a separate, in the same figure window, but in a separate graph page. I will keep my work here and typed the word figure so that I will open a new figure window, just to show you the difference between this and calling sublet. So what figure does is basically opens a new figure window for me. Let me show you. So this is figure, this is figure 1, which is the results of the plotting command. This is an empty figure window that's waiting for my next plotting command. I will call sublet, which requires me to specify how many rows I want and how many columns I want. I only have two plots to do, y and f. So I'm gonna say 2 by 1. I want 2 rows and 1 column. So I will see one graph on the top and one graph at the bottom. In the first location, I want to plot say y of x. Plot x comma y. This is y of x. And then you can add labels like you normally do. So this is my x label. Y label is actually y. I'm gonna skip the title this time, it's fine. And I will call subplot again to plot f of x. But let me run this file to show you what we have so far. I will have two figure windows. The first one is from the first plotting command. The second figure window has 2 spaces in it. In the first space, I have the plot of y of x. Okay, I'm gonna continue my code by again copying this part. Simply only change the location because the grid size is still the same. It's always going to be a 2 by 1 in my case. Depends on how many plots you have. Okay, now this time I'm going to plot f of x, so I will change the y label to f. Okay, what we see on top is x squared. The graph on the bottom is x squared divided by sine of x squared plus 1. Okay. Now this is all there is for subplots, but remember, it depends on how many graphs you have as a total. If say you have 6 graphs together, then you could do 2 by 3 or 2 rows and 3 columns, or you could do 3 rows, 2 columns. You can do 1 row, 6 columns, 6 rows, 1 column, and so on. And the location is the only thing that will change, because every time you call a plot, the plot function, you will put it in a new location. And remember that subplot doesn't plot anything for you, it simply creates the grid for your plot. You will still have to call the function plot. So the function subplot waits for your plot command. Next, we will cover for loops. This is the template for the for loop. You don't need to use brackets or curly braces. The only keyword that you need is for, and then you have to specify the iterator and then its range. After that, you will put your code that you want to repeat, and then you have to use the keyword end to close the for loop. I'm gonna do a quick exercise on how to use for loop. For this exercise, I will plot x raised to the power n for each of n is equal to 1, 2, until 6. So n ranges from 1 until 6. I have this written here already. Okay, and I will complete this code so that I will plot x raised to the power n using subplot. Okay, let me type figure so that I will create a new figure window. I want to use for loop on for n is equal to 1 through 6. Okay, I want to plot x raised to the power n. Okay, I'm not given the values for x, but I want simply the shape of it, the shape of x raised to the power n for the case of x squared, x raised to the power 3, and so on. So here I have to judge, or I have to make a decision on my range for x. The value of x will not change within the for loop, I mean. So I will create it outside the for loop instead of having to call it 6 times. I will have a negative range, so maybe -5, increment by 0.1 until you reach 5. So this is the x-axis. The y-axis will change in each subplot. I will type subplot. I have 6 total figures, so I'm gonna say, or maybe I want 6 rows, 1 column. And then here I'll put the location. Every time I enter the for loop, I want a new location because I don't want to override all the figures. So I'm gonna use n as the location number. The first time I enter the loop, I will plot at location 1. Second time I will plot at location 2, and so on. Then I will call plot on x. The x-axis is x, the y-axis will be y. Y will be evaluated again every time I enter the loop. And you can maybe add an x label. It's going to be x. Y label will be changing every time, so I'm going to say x raised to the power n, something like that. So this will concatenate the new value of n with x raised to the power. Okay. Don't forget to end the for loop. We do not know 100% whether this code will work or not. That's why we have to test it. So I'm gonna run it to see if we get the correct graphs. The graphs are correct, but they're a bit squeezed. So I'm gonna change the size or the dimension to, for example, I will try 2 by 3, 2 rows and 3 columns. This is a bit better to look at. So we have 6 graphs. This is x squared, x cubed, and so on. And see how the labels are correct. This is x squared, x cubed, and so on. Now we'll go over user-defined functions in MATLAB. Remember, there are tons of built-in functions in MATLAB, including, for example, the sine function, the length function, size, which we used earlier. You can also create your own user-defined function in MATLAB, and this is the template for creating a function. The template can be created through MATLAB. You will have two outputs in the template. This is the function name. These are the inputs. You can add more inputs if you want, and you can also, of course, add more outputs. Or you can remove one, so you'll end up with one output only. You can remove the second input, so you'll have only one input function. And within the function definition, you must provide a value for each of your outputs, because that's the whole purpose of calling a function, is to output something, especially if it doesn't plot anything. Okay. This is an example of calling the function myFunction and putting the output of it in a variable named y. So y is equal to myFunction, inputting 1 and 2. And this function clearly takes two numbers and outputs the results of multiplying them together and dividing them together. Okay. I will explain user-defined functions through an example. The example says, create a function that outputs x times cosine of x. And here I'm told that the function must work with vectors as well as scalars. Meaning, if x was a vector, the function should not give me an error. Hint, I have to put the dot before the operator, before the multiplication between x and cosine. So I will start with a template given from MATLAB, especially if you're new to this. So I'm going to create a new function file by clicking on New Function. This is the template. My function will have only one output, so I'm going to erase both outputs and replace them with y. I'm not told what function name I should use. I'm going to call it x cosine, x cos. The input for my function is just one input. I will call it x because it will output x cosine of x. And I have one output. I said it's called y. I must define it within the function, but let me erase everything else here. You can add a definition or a description for your function. As a comment, you can say this function outputs y is equal to x times, I'm going to write it as a mathematical expression, x cosine of x. I will say it also works with arrays. So I only have one output. I must define it before exiting the function. I will say y is equal to x dot times cosine of x. Now this function is complete. The only purpose of creating a new function file is to use the template. Once I'm happy with it, I will copy the code or cut it, up to you, and then close this window. And I will scroll down towards the end of my file, somewhere here, and paste this function. Okay? All function definitions must appear at the end of the file. I will write this as a note. All function definitions must appear at the end of the file. This is, by the way, an error message that MATLAB will give you if you have this function placed somewhere else that's not the end of the file. If you read that error message, you should know that you have a function not at the end of the file. Make sure you place it there. And I'm gonna have my function a bit clean by putting a semicolon. So every time someone calls the function, I'm not gonna output the results unless they want to output it. Okay. Now I'm gonna call the function to test it. The way to test the function or user-defined function is exactly the same way as you use built-in functions like the cosine, the sine, and so on. I'm gonna try pi, for example, and now I will click run. The output will be displayed in the command window. So this is x times cosine of x for the case where x is equal to pi. For example, 3.14 times cosine of 3.14 will give me a value very close to this. Yeah. Remember, pi is not exactly 3.14, but here I rounded it. Or you can use a calculator if you want to verify, or simply actually input the built-in variable pi, cosine of pi. It will give you exactly what the function was designed for. The last thing we'll cover is the function Linspace. This slide summarizes the difference between Linspace and using the column notation to create an array. Basically, Linspace will create an array of n number of equally spaced points, starting at A, ending at B, and this is the number of inputs. So that's the syntax for using it. We've previously introduced using the column notation to create an array of a given starting value, specific increment value, and limit. So that's the syntax for using the column notation. I will use the command window to explain the difference between the two real quick. So let's assume I type 1 increment by 0.5 until you reach 3. This is what you will get. So you always specify the start value, the increment value, and your limit. But with Linspace, the first input for the function Linspace is the starting value. The last input is the ending value. For example, I will use the same one here. The last input, so first starting value, ending value, and how many points you want. If I want 1, 2, 3, 4, 5, if I want 5 points, I will get exactly as something that looks like this exactly. So 1 increment by 0.5 until you reach 3 is equivalent to start at 1, start at 1, end at 3, and I want 5 points. So the difference between the two is basically, if you know exactly how many points you want, then you should use Linspace because it allows you to specify how many points you want without having to worry about what increment value you should use. Okay, because with this notation, you have to do some calculation to figure out what the increment value should be for you to have a specific number of points. Okay, so let's assume we want, I will write it as a comment, we want 10 points between 0 and 5. And let's say not 0 and 5, let's use something a little different. 10 points between 0 and 3.5. Okay, then I will call Linspace between 0 and 5. And how many points I want? I want 10. So I'm going to say 10. The length of this will be 10. Okay, I'm going to hit enter. I will see 1, 2, 3. If you count them, they're actually 10 points. The first value is 0, the ending value is 5. Okay, so as a kind of fun question, I'm going to say correct or false. Length of Linspace 0, 5, 10 is equal to 10. This number is equal to the length of the array that Linspace will output in this case. So this will give you logical 1. Okay, I'll do one last example. Linspace, start at 6, end at 7, and I want exactly 4 points. So start at 6, end at 7. Make sure that the increment value is constant such that I end at 7 and I get only 4 points, because the definition of it is again linearly spaced points. Len is short for linearly spaced and then points. If you ever forget about how to use any of the functions that we learned, you can type help followed by the name of the function. For example, help Linspace. And even if you misspell it, MATLAB will tell you, did you mean Linspace? It will correct you on how to spell it. A common mistake is to say line space. It's not actually line space, it's lin space. Linearly spaced vector. Okay, this is all I have in this video. Thank you for watching and good luck.